Hello student, the question says in RLC series circuit, the potential difference across each element is 20 volt. Now the value of the resistance alone is doubled, then potential difference across R, comma, L and C respectively is. Now let us look into the circuit. It's an RLC circuit and each one has 20 volt, 20 volt, 20 volt. Let us assume it is connected to an AC voltage of VRMS and this is the current IRMS is flowing through this. We know IRMS is VRMS by Z. Z is basical impedance. The formula for impedance is root of R square plus XL minus XC whole square. Another important formula is VRMS is equals to root of voltage across resistance square plus voltage across inductor minus voltage across capacitance whole square. So if I substitute the given input here, I will get VRMS is equals to, since VL and VC are equal, it will become 0. I will get VR. So it is 20 volt. So I got the RMS voltage as 20 volt from this question. And not only that, in series, the current would be same in all three of them. When current is same and voltage also same, we can tell that all three of them have the same value of reactance. Like example, here it is 20 volts, here it is 20 volts. If I ask you what is the voltage across inductor, voltage equals to IRMS. In this chapter, rather than using resistance, we use something called reactance into XL. And voltage across capacitance equals to IRMS into EXC. We got same VL, same VC. IRMS anyway same. From this I can conclude that XL value is equals to XC. Not only XL equals to XC, since this is also equal, so we can directly write the magnitude of R is equals to XL is equals to XC. All three are equal. This is the conclusion that we can draw from the given circuit. And one more, if XL equals to XC, this also means right now we have this entire circuit is under resonance. What is resonance right now I won't discuss, but remember, if the voltages are equal, that means their reactances are equal, and that situation is called as resonance. Now let us get into a situation where the resistance is doubled now. That means rather than R, I have to use 2R. So if the resistance got doubled, it won't be 20 volt, 20 volt, 20 volt anymore. So this is my 20 volt. Let me call this current as I2. So we can get I2 equal to VRMS by, at resonance, XL would be equal to XC. So if I substitute XL equals to XC, the contribution of this is 0. So Z is directly equal to R. So we can, so by Z and VRMS by, what is the Z value? Z value is simply 2R. I can substitute VRMS as 20. So I2 would be 20 by 2R. So I got I2 value as 20 by 2R. Now let us find what is the voltage across resistance. Voltage across resistance is 20 by 2R into resistance. V equal to I you got it, into R. So we get it as 20 volts. Just remember this, at resonance, whatever is the RMS value, this resistance also will have the same value. So we can directly answer it. But if I try to find what's the value of voltage across this, so it will, current is I2, 20 by R, into XL. We got previously that XL equals to R. It still stayed the same. We did not change the values of inductor and capacitor. So I have to still substitute in place of XL R value only. So you will get 20 by 2, which is 10 volt. Similarly, if I look at VC, it would be 20 by 2R into XC, which would be again 20 by 2, which is 10 volt. To explain you, I took so much time. But what is the practical way to solve this problem quickly? The practical way to solve this problem quickly is, as soon as you read, we realized that VR is equals to VL equals to VC. Quickly you have to tell that this is under resonance. So XL equals to XC, and you have to quickly find VRMS is equals to 20 volts. And after realizing that VRMS is 20 volts, if resistance doubles, current becomes half. If current becomes half, and at resonance, VR dash does not change. VR dash would be still VRMS only. That means it will still be 20 volts. But the issue is that VL and VC would become half. VL dash and VC dash would become 20 by 2. That is 10 volt. This quickly we do it in our heads only. We are not supposed to like sit and solve this with pen and paper. Hope you understood how I have solved this. So the correct option for this would be 20 volt, 10 volt, comma 10 volt, which is my option A. Hope you understood how I have solved. Thank you.